Good morning. Today we are going to be learning about classifying rational numbers, and it's going to be 6.2a. This number is going to be a big reference number for your notes connecting to your classroom assignment. So classifying numbers, when we start out, there are a few definitions that we need to go through before we can actually identify what these mean. So if we start with a rational number, is any number that are all whole numbers and integers. Okay, so rational numbers are whole numbers and integers, and all whole numbers and their opposites, which means they're negatives, are called integers. Okay, from there we have a whole numbers are all counting numbers, including 0. Okay, so whole numbers do actually include 0. The difference here is that counting numbers are all whole numbers except 0. They are numbers we use to count. So if you think about it, counting numbers are kind of what 5-year-olds will pick up on. So 1, 2, 3, 4, 5, so on and so forth. They don't know 0 yet because they don't understand that you can't have nothing. Then we grow up and we learn about whole numbers, and whole numbers include 0 because now we're more refined. We know that nothing can exist. Okay. And now, as 6th graders, we're introducing a new term called integers. Integers are whole numbers and counting numbers, so that 0, 1, 2, 3, 4, so on and so forth. And now we have something that's called an opposite, meaning negative. So now we can have a -1, a -2, a -3, so on and so forth, all the way to infinity. And then rational numbers are all of these and any number that you can create, okay? So if we look at like a Venn diagram, we have to think about our whole numbers. Whole numbers, again, are everything including 0 all the way to infinity. Integers, the next bubble out, is going to be any value that is positive or negative. And then our rational numbers are going to be all numbers, including decimals, fractions, positives, negatives, 0, everything, okay? So our directions say place the values where they belong in the diagram. So we have these numbers. I'm gonna start with the top row, work my way across, then move down, okay? So I'm given the number 0. Well, I have the options of rational, integer, and whole number. I wanna put it in the smallest circle that it can belong into. So let's start at the top, rational number. All numbers are rational, so it can go into the circle, but let's see if it can go into a smaller one. Integers. Well, integers, by definition, are all whole numbers and their opposite. So 0 is a whole number, meaning that it's not part of something, is an integer. But let's see if it can go into a whole number. By definition, a whole number are counting numbers including 0. So because we have 0, 0 is going to be classified as a whole number. So I'm going to put 0 under whole number in the whole number circle. Okay, I'm going to cross it off just so I don't use it again. And now I have -23. Now we need to be careful. Just because we see that negative sign out front of something does not mean that it is an integer. Sometimes they try to trick you, so we have to be careful, okay? So let's think about the number itself, 23. Well, 23 is a whole number, We've known the number 23 since probably about first grade. And we would put it in here as a whole number. However, because it's a whole number with a negative, by definition, a whole number and their opposite, meaning negative, are called integers. So because we have a negative whole number, negative 23 will be an integer. And I'll cross it off my list. Now the next one in line is a little bit tricky, and I'm going to zoom in just real quick so you can see what I'm talking about. Do you see how there's the decimal in there? And it's got the negative? So we need to be careful. This number is not a whole number, which means by definition of an integer, it is a whole number and their opposite. This is no longer going to become an integer. And the reason being is this number is not a whole number, which is what integers must be. So because this number is a decimal, it is going to be a rational number only. Okay? I understand that it's negative, but remember, rational numbers are also integers, meaning that they can be negative. So this decimal is kind of like the trump card. They're going to override anything that you see, okay? So a negative decimal is going to be a rational number, and this goes away. Our next value is a mixed number, meaning that it's mixed. It's got a whole number and a fraction. These go together. They cannot be separated. So we have 3 1/4, and it is not a whole number, so I cannot stick it in this whole number circle. It is also not a whole number, so I cannot put it in an integer. I understand that it's positive, but it cannot go in there because it has a fraction. So because of this fraction, it is going to go under rational numbers. Oop, it's a 4th. Okay. Fractions go as rational numbers. Our next value is 16/4. But if I draw this over here and I say 16/4, as a 5th grader, you learned how to simplify fractions. And we learned that you can divide by their greatest common factor. So we're going to divide by the GCF, which is greatest common factor, okay? Between 16 and 4, the greatest common factor is 4, okay? So if I take 16 and divide it by 4, I get 4. If I take 4 and divide it by 4, I get 1. So therefore, I am given the fraction of 4, because 16 became a 4 by our division, over 4 divided by 4 is 1. Whenever we see a fraction over 1, you're going to be very tempted to put it as a rational number, because I just told you that rational numbers are fractions. However, when a number is over 1, you are dividing by 1. So 4 divided by 1 is 4, right? So in that case, this actually means the whole number of 4. So they tricked you into thinking that this was a rational number fraction, when in reality, since it equals the number 4, it's going to be a whole number. So every time you see a fraction outside of a mixed number, so just a regular fraction, you must simplify first. Please be very careful with this, okay? So now that we have our fraction done, let's move on to the next value, and they give us 165. If I went and asked a 3rd grader, they would say, oh, that's a whole number, because it's not positive, or it's not negative, excuse me. It's not a fraction, and it's not a decimal. So we'll have 165 as a whole number, okay? This last number is a decimal, and we've learned that all decimals are rational numbers. So we'll add this decimal to our rational numbers box. Now you might be thinking, what is this arrow? This arrow means that numbers can move out in rank, but they cannot come back in. So let me explain. A whole number is an integer. a whole number is rational because it can move out in the circle, okay? A integer, if we move outward, an integer becomes rational, okay? And then rational, if we move outward, since it includes all numbers, that's it, okay? What it means is you cannot go back into the circle. Never, ever, ever. So rationals are not integers, and integers are not whole numbers, okay? We cannot move in the circle. So think about it like a firework. Fireworks explode from the center out, okay? Once the firework has exploded and you see all the pretty colors, it doesn't circle back into itself like a black hole. It doesn't consume it, okay? So everything must move outward. To help clarify this, let's go through our word problems. Number 1, it says which statement is true. That word true is going to be very important, and I need you to understand that we're looking for something that is correct, okay? So we have 4 options, A, B, C, or D, and we need to prove which one is real, which one is false, okay? Letter A says irrational numbers are also integers. When they give you something and then they say something else, that's point A, this is point B, meaning this is where we start, this is where we end. So if I start as a rational number and they say that it becomes an integer, I have moved in circles. So I've moved down, inside. We are not allowed to move inward. We are only allowed to move outward. So because they ask us that it goes from rational to integer, this is not true or false, okay? Letter B says integers are also rational numbers. Integer is my starting point, rational number is my end point. So if I start with rational numbers and I move towards a rational number, I moved out of the circles. I moved outward. So integer to rational, because I moved in the correct arrow direction, this is going to be true, okay? Which matches my answer choice, but I'm going to prove to you that these other 2 are not true, okay? So letter C says integers are whole numbers. So again, I'll start with integers, and I'm going to move towards a whole number. Do you see how I moved down to a smaller circle? I'm not allowed to move down. Remember, our arrow points out. So I can't move down the circle, so this statement is false. Rational numbers are only negatives. Rational numbers are not only negatives, because if we look at these 2 values, they're both positive. Whole numbers, by definition, are integers. Whole numbers and opposites, meaning we can have positive and negative. So because it says that rational numbers are only negative, this word only makes this statement false, which makes our only true statement letter B, okay? Moving through this, number 2, it says, which number does not represent a whole number, okay? So we have 2 keywords here, not and whole number, okay? So that means we're going to eliminate anything that is a whole number. If I look at number or letter A, it gives me 3/1. Something we discussed over here when classifying is that any number over 1 is equal to just the numerator or that top number. So 3/1 is actually equal to the number 3. 3 is a whole number, but I want something that is not. So I cannot choose A because it is a whole number. Letter B gives us the number 20, and 20 would be a whole number. So because we're looking for something that's not a whole number, B is also not my answer, okay? Letter C gives me negative 10. If we look at just the number, I'm given the number 10. Number 10 is a whole number. But because of this sneaky little negative sign, this actually becomes an integer. Okay? Because by definition, a whole number and their opposite, meaning negatives, are integers. Whole numbers that are negative are called integers. So this is an integer, which means it's not a whole number. Okay? Let me prove that D is also not your answer, just to double check our answer before I circle C. 4/2 is a fraction, which means it's a rational number. But we learned with 16/4 that we must check all fractions. So 4/2, I'm going to divide by the GCF. Well, the greatest common factor between 2 and 4 is the number 2. They both evenly divide by the number 2. So this means I'm going to start a new fraction, and I'm going to divide both numbers by 2. So 4 divided by 2 is 2. And 2 divided by 2 is 1. But just like letter A, we learned that anything over 1 is just going to represent the numerator. So it becomes the whole number 2. 2, from our original question, is a whole number, but we want something that's not. So because 2 is a whole number, it cannot be our answer choice, which further proves that C is your answer. Okay? I'm not going to explain 3 as much, but we'll go into it. It says, which of the following is an integer? So we've got that word is, but not a whole number. Okay? So we need to be careful. We need an integer, meaning positive or negative, and we need it to be a whole number. Now, remember, integers are positive and negative whole numbers, and whole numbers are all counting numbers, including 0. So letter A is a whole number because 4 is a whole number. We want something that is not a whole number. 4, oh, I read this wrong, excuse me. I just made a mistake. It is an integer, but not a whole number. So because this is a whole number, we have a possibility. It is not a possibility because it's not a whole number. Okay. 13/2, fractions. We know that fractions are not integers or whole numbers. However, we must check a fraction. 13 and 2 do not have anything in common. So it actually stays a fraction. And that is because 13 is prime and so is 2. Okay. 13 and 2 have nothing in common, so it stays 13/2. This is not a fraction, or this is a fraction, so it's not an integer, and it's not a whole number. So we need to move on. -8. This is an integer, so that checks that box, but it's not a whole number because it's negative. Because of this negative, this makes this wrong. Anything over 1, even though this is a fraction, they're tricking you, becomes just the whole number 100. 100 is a whole number, and we want something that is not a whole number. Okay. I made a mistake. So we're just going to ignore everything for question 3. I'm so sorry. Beatrice counted the number of grapes in the cluster of grapes. Beatrice listed the number as she counted, which best represents the number she listed. Our options are rational, integers, whole numbers, and integers again. Okay? Let's be careful about something real quick. If they give you a number twice, it is never going to be the answer. Okay? Never, ever, ever. Let's look at our choices. we have a decimal, a whole number, a decimal, and a negative. Decimals are going to be rational numbers. 3 is a whole number. A decimal is a rational, and negatives are integers, as long as they are a whole number. 8 is a whole number, so it's an integer. Now, I understand that we have rational whole, rational integer. However, we need to be careful because it says we want to know one that can name all clusters. So which word says that it can be a whole number, an integer, and rational? A rational number. Okay. Number 5, the table shows the number of goals scored during a soccer game. Which number represents a whole number? Whole numbers are your counting numbers. That means 0, 1, 2, 3. We do not have negatives, we do not have fractions, we do not have decimals. So if you look at it, that's A, B, C, and D. Okay? We want one that represents a whole number. Two is an integer. And that is because it is a negative 2. Okay? B is 0, so it is a whole number. C, because it is between 1 and 2, it is technically representing a half. Fractions are not whole numbers, so it cannot be C. It was not A. And D says positive 5. Okay, so this, by definition, is a whole number, correct? Okay. So number 5 is going to be B and D. You can rewatch this video, pause it, rewind it as many times as you need. There's also a second video attached to this that does a shortened version. So if you look at this video that is roughly 25 minutes long and you go, no, please make sure that you do watch the other one. But this will be a good tool for later if you've missed our lesson. Good luck. Let me know if you have problems.